So today we're going to be covering the Phidgets Getting Started kit with Python. So most of you should have a Getting Started kit, or Getting Started kit should be in the mail if you're attending the webinar. I hope everyone's doing well and is surviving the first few weeks of school. I know it's kind of a crazy time, but hopefully everybody's safe and healthy, and things are going along quite lovely. So the Phidgets Getting Started kit. The first thing you want to do when you're using the Phidgets Getting Started kit is navigate to the Phidgets education page. So I'll just highlight it here. So the phidgets.com/education. So this is where all of the Phidgets education information lives. This is really your website to go to rather than phidgets.com. So you'll see a few tabs up at the top. Learn, so that's where all of your students' programming is going to be. So all the lessons, all the tutorials, all the projects will live under Learn. Educators is a resource for you. It provides some real-world examples and some other teachers talking about their experiences with Phidgets, and it will be added to as time goes on. The next tab is Buy. So that's where you want to go when you want to purchase a Phidget, either the Getting Started kits or individual Phidgets, or things like a rover kit. Next, we have News. So that's where you're going to have all these webinar recordings posted. It's also where all the new webinars are going to be posted, and you can sign up there. So that's a good area to check if you're looking for more webinars or for resources from past webinars. So if you couldn't attend the rover webinar or one of the advanced devices webinars, they are recorded there. But today is all about the Getting Started kit and Python. So for the Getting Started kit, first place you'll want to navigate is Learn. So we click on Learn, you'll notice a few different places where you can go. What Are Phidgets is a great resource for students to learn about what they're learning about. A lot of times tools are handed to students and they don't really know why. The benefit of Phidgets is it is an industry used tool. So the light sensor that a student will get, or the humidity sensor the student will get in their Getting Started kit, is in fact the same product that an engineer, scientist, researcher is going to be using in their everyday working. So that's a great resource for students to learn about the why they're learning Phidgets. The next is Getting Started. So that's what we're going to focus on today. Device tutorials. So this is a good resource after the Getting Started kit to learn about those individual devices, have some practice with them. So your thumbstick, your RFID, any of the individual Phidgets. And projects. Projects is where the rover kit lives. Individual Phidgets have projects associated with them. There's also extensions of that Getting Started kit in the project section. Like I said, today is Getting Started. So there's actually two ways to navigate to the Getting Started page. The one way is the way I just showed you. The other way is using the link that's on the side of your Getting Started kit, phidgets.com/start. That will take you directly here. It might be a bit of an easier path for your students if they tend to get distracted. You can send them right to that course. So this is the Phidgets Getting Started kit course. You'll notice there's a few sections, and what's new from the previous webinars is we actually added an advanced lesson section. So we're going to be briefly touching on that as well in this webinar. But to start out, the first thing you have to do is set your language and your environment. So today I'm going to be working on a Mac using Python and Thonny. However, as you can see, we have a lot of different options for different languages and development environments that you can use in your classroom. So if you're using Mac computers, or if your student is using Mac, they can use Java, Python, C#, and Swift. If you're using Windows, it's Java, Python, and C#. And as you can see, there's a different development environments: NetBeans, Eclipse, Thonny, PyCharm, PyScripter, Visual Studio, and Xcode, so students can navigate and customize their path. But as I said earlier, today we're going to do Python with Thonny. Thonny is a really great, simple development environment. If you haven't chosen a development environment or are looking to switch things up, or in fact are using Thonny, you're all set. Thonny is really great because it comes packaged with Python, so it's only a single download. So thonny.org is where you'll find that download. You can download it on Windows or Mac. Again, the installation is really simple. So if you're getting students to work from home and they have to install a development environment and they're using Python, this is a really great one because it is so simple. So after you select Thonny, we select Done. Now the entire Phidgets website will be displayed in Python with Thonny. So no matter where you go on the website, you will be seeing Python code. So you only have to select it once, and then your web browser will remember that. If a student is having issues, one of the first places to look is up here in this top corner. So you'll see the Python logo. Sometimes if a student accidentally selects the wrong language, they'll get some wacky errors happening because they'll be trying to put a Java code into a Python development environment and not really know what's going on. So that's your first place to check if there's an issue. So after we set your environment and the language, we move on to the setup. So today I'm actually not going to be reviewing this build kit. However, we can take a look. So the build kit, if you haven't built your Getting Started kit yet, consists of step-by-step instructions with images about how to install the buttons, how to assemble the LEDs, how to connect your Vint hub. So the Vint hub is a really essential piece of Phidgets. Almost all of our Phidgets will use a Vint hub. As well, the port numbers are quite important, so make sure your students are plugging in their buttons and LEDs into the correct port, because that will matter later on. And finally, you add that humidity fidget onto the back of your box. So once you're finished assembling, we're going to go on to configure. So configure is where we set up Phidgets with our development environments. We have to add Phidgets into our development environment so we can access the libraries and things like that. So for Thonny, the steps to configure Thonny with Windows or Mac are quite similar. They're a little bit different. If you are working on Windows and want those step-by-step instructions, if you go to the previous Getting Started with Python webinar, the instructions are listed there. However, they are extremely similar to the instructions that we are using today. So one of the major differences between the Windows and Mac installation of Phidgets is that you have to install the Phidgets library onto your Mac. So you will have to download that onto your computer and get that installed. If you're using school computers, you may have to contact your IT department to get those installed onto your Macs. If you're a student at home, they can install that onto their computer. So once you have the library installed and download, you'll want to open up your Thonny environment. So the first thing you'll want to do when you open your Thonny environment is navigate to Tools. Then you'll want to go to Manage Packages, and you'll want to search for Phidget 22. This will be slightly different than your Windows environment, Windows, you'll want to search for Phidgets 22 native. So it's a slight difference there. Other than that, the steps are the same. So I already have Phidgets 22 installed, but you just want to install it. And that's it, you're done. And then save your project as getting started, getting underscore started. And then you're ready to go. So it's really a simple configuration with Thonny, which is, again, why we love it so much. There's very few places where things can go wrong. And again, the only difference between Windows and Mac is this Phidget 22 native. And just like that, we're ready to go and ready to move on to some content. So the setup is very brief. Students can get into the real learning very quickly. It's not a lot of waiting time for students to get into code. So then we have two major sections of lessons in the baseline Getting Started course. The first section is Simple Phidgets, so that reviews your LEDs and your buttons. The next one is your Smart Phidgets. So that's going to talk about your humidity sensor. In fact, most of the Phidgets students will encounter going forward, the light Phidget, the thumbstick Phidget, the RFID, the pH Phidget, the spatial. All of our Phidget, or most of the extension Phidgets are actually Smart Phidgets. So students learn about both types. And then there is a challenge followed by those new advanced lessons, which we are very excited about. So let's start off with those simple Phidgets. So lesson 1, blink LED. So all of your lesson formats will look very similar. They all will start off with a brief description about what they're going to be doing in the lesson, followed by some sort of GIF or image of what is going to happen when they run their program, followed by a code sample. So this code sample will actually perform what's happening in that GIF, so students can see it in action right away. After the code sample, there's always a practice section to get students engaged in that code. So they aren't just copying and pasting and moving on. They actually have to engage and learn about what's happening in that code. And then lastly, there will be a troubleshooting section that goes over major errors that can happen. Things like your Phidgets aren't plugged into the right Mint hub, you're using your Phidgets in multiple programs, things like that. So this just provides students a little bit of like independence as they're going through their course. So we're trying to keep students feeling that independence and feeling that self-guided nature that is possible through the online course. So let's take a look at this code. So you copy the code sample in this top right-hand corner here, and then we can just paste it in. There it is. So now I'll get everyone to look up in the corner at my screen here. And I'm going to run this program. And you'll see the LED turn on and off. I'll do that again because it is fairly quick. On and off. So what's actually happening in this code? So Phidgets code always follows the same basic steps. The first thing we're going to have to do in Python is add our Phidgets libraries. So in this case, we have to add the Phidgets library and the digital output, which is what the LED uses, as well as the time. Next, we will want to create our objects. So the red LED, like I said, is a digital output object. So we want to create that object. So that just provides a software representation of the physical LED. Next, we will go to the address section. So that's always your second, well, almost always your second step. This tells your software object where to find your physical Phidget. So we're setting the hub port. So that hub port is where it's plugged into on that Vint hub. In this case, we are plugged into number 1. And then we're setting our hub port device to true, which is done for all simple fidgets. So we've created our software object. We've told our software object where to find our fidget through addressing, and then we're going to open our fidget. So that's creating that communication line between that software object and that physical fidget and getting them to start communicating. This can take a second, so we always have an open wait for attachment, and that will have a 1 second delay just to let give the program some time to connect those two things, and before we start using our fidgets. If we don't give them that time, we may encounter errors. So after we create, address, and open, we'll move on to using our fidgets. So in this case, we set the red LED state to true. So that turns our fidget on. Next, we're going to have a sleep for 1 second. So that just keeps that line of code running. So it keeps our LED on for 1 second. And then we're going to turn our LED off, which is setting the state to false. So you may be wondering where students find this information. The comments all have a scroll over feature, which explains what that chunk of code does. So students can explore the code, learn about what each line of code does, and really investigate. Now, what forces students to get that investigation happening is this practice section here. So in all of our practice, we're going to be asking students to locate and modify key features in the code. So in this case, modify your code so the LED stays on for 2 seconds. So students have to go and explore and figure out which line of code actually keeps their LED on. So in this case, they're going to scroll through the comments and see that the sleep command actually keeps their LED on. Next, we're going to modify our code so the LED flashes on and off 3 times. Again, what is making my LED turn on and off? And lastly, we're going to modify to flash our green LED. So this is a key question here. So this really looks at that address section. So we learn here that addressing is actually telling which port we can find that fidget. So in this case, the red LED is connected to 1 and the green LED is connected to 4. So with all of that, we're completing lesson 1. We move on to lesson 2. So lesson 2, we learned how to read our button. Again, we have a GIF showing what students can expect as output. With Python, you'll either see a 0 or a 1 displayed. Next, we have that code sample. And then we have our practice questions. So again, let's see our code sample in action. So we just copy and paste it in here, and we run. So you'll see the output as button state 0. It's a bit bigger here. Bigger. Okay. We can see the button state is 0. If I press my red button pressed, you'll see the button state going to 1 in the console. When I release that, it goes back to 0. Again, I press it, go to 1, release, go to 0. We are going to stop this program before we continue. Okay, we can make that a bit bigger. So as you can see in the code as well, which I didn't mention last time, is those rollover comments are also pasted into the student's code. So if they do just have the code sample and they don't necessarily have the website handy, they can still understand what each line of that code is doing. So again, let's review that code. So the first thing we're going to do again is import those Phidgets libraries so we have access to all those good Phidgets things. Next, we are going to create our software object. So in this case, a button is a digital input object. So we're going to make that software representation of that physical Phidget. Next, we are going to address our Phidget. So tell our computer where to find the Phidget. In this case, the red button is plugged into hub port 0. So we set hub port to 0. And then because we are using a simple Phidget, we're going to set this hub port device to true. Next, we are going to tell our Phidgets to start talking to the computer, or our computer to start talking to our Phidgets in this case, leaving that time for that connection to happen. Next, we're going to use our Phidgets. So in this case, we're using an approach called polling. So polling is this using the infinite loop to get data continuously from our button. So we're just checking our button. Here we have a sleep time, which manages our button's data collection. So again, we have those rollovers to learn about what the code does. Our practice sections then get students engaging in this code. So the first thing is learning about that polling method. So modifying the loop repeat time to 10 milliseconds, 1000 milliseconds, and 5000 milliseconds to see how that time change changes the behavior of the button. So are we getting more events? Are we getting less events? How does that change the responsiveness of our program? So really learning about how we get data from Phidgets. Next, we are going to return to that address section. Again, switching the red button for the green button, finding out that it is in fact changing your hub port number, not your variable name, creating that separation between the color and what's actually happening. And lastly, modify your code to only print when the button state changes. Now, this is a really, really, really important question for students going forward. So make sure you're giving students feedback on this question before you continue, as it is reused again in multiple projects and throughout the Getting Started course. And then again, we have that troubleshooting section. And with that, our button is complete. So to finish out our simple Phidget lessons, we're going to be learning how to use the button and the LED. So all 4 of our simple Phidgets at once. So combining the different objects. So again, we have a GIF showing what's happening. Next, we have our code sample. So here again, we're importing the library. So we have to import both digital input and digital output in this case. We have to create an object for each one of our buttons and each one of our LEDs. So creating that software representation. Next, we have to address each one of our Phidgets. So again, locating which port they're plugged into and setting those proper port numbers. So again, telling our program where to find our Phidgets. Next, we have to open each one of our devices. Each device needs to also have that wait time, so you can connect to each individual device, so your software objects are good to go when you get time to use them. Next, we are going to use our Phidgets. So again, using that polling method to get data from our buttons. So in this case, if the red button state is true, so if the button is pressed, the red LED will come on. Next, if the green button state is pressed, the green button will come on. When it's released, and either button is released, that light will go off, setting the state to false. And again, having that sleep timer so we're not continuously checking, we're getting a nice reasonable flow of data from our button. Now, I'm not going to demonstrate this code just because I'm trying to get through all the lessons, but you can run that code yourself. For the practice, we're going to be mainly focusing on the connection between the red LED and the red button, and the fact that there aren't any connections other than what you're programming. So putting that emphasis less on the color, more on the program, and showing that customizable nature of Phidgets. So for example, turning the LED off when the button is pressed and on when the button is released, breaking that intuitive connection that some students may have and showing that it is in the code. Next, we're going to have the green button control the red LED and the red button control the green LED. Again, showing that, in fact, it is your code that is connecting these devices, not the color. Lastly, we're going to count the number of button presses. So this is reliant on the completion of that previous lesson question 3. So lesson 2, practice question 3, again, is used multiple times. So that's an essential feature of this last question, which I should mention, we do have solutions for all of the questions and projects that are on the Phidgets website. We do not post them publicly, so your students cannot find them, but we do have those. So if you are looking for solution guides, just email us at education@phidgets.com, and we're happy to pass any code you have questions about onto you. So with that, our simple Phidgets lessons are completed. And we're going to go on our first practice challenge. So again, students get into code quickly, they get active in problem solving quickly with those practice questions, and then after 3 brief short lessons, they're creating something. They're creating a tug of war game. So the tug of war game actually builds on what students have done previously. So that last question in lesson 3 is actually used right away, where each player is assigned a button, and the button that has been pressed 10 times wins. So again, we're counting those button presses. And then whoever wins, the LEDs will flash. So we're applying what we've practiced and what we've learned in the first 3 lessons into a fun game. Again, getting students engaged quickly in code and getting them doing something fun and creative and really practicing those problem solving skills rather than just instruction following. And with that, we're going to finish these simple Phidgets lessons. Next, we move on to our smart Phidgets. So our smart Phidget in this case is our humidity Phidget. See right there. So once again, we have a GIF showing what you can expect from your output, a code sample. So one thing you'll notice about this code sample, if you're looking very closely, is that there's no address section. So what differentiates a smart Phidget from a simple Phidget is that address section. So we don't actually need to address that smart Phidget. They can identify themselves to the computer. So we don't actually need to tell our program where to find them in most cases. In the advanced lessons, we will see a case where we do need to add in that address lesson. But for your base case, you're good to go without address. So here again, we're importing your Phidgets libraries. We're creating a software object. In this case, it will be a temperature sensor. We're going to open that temperature sensor, again, having that delay so you have time to connect the software and the physical. Then we're going to use our Phidgets, again, using that polling method to pull data from our temperature sensor. So again, I'm not going to run this code sample. If you do want to see it running, it is in a previous webinar. The previous Getting Started webinar, I should say. So again, we have those rollovers showing students or telling students what each section of code does so they can investigate and dive in. We have the explanation about why they don't see addressing, and then we have our practice questions. So in this case, we're using getting students to identify where the output is, and doing some simple math to convert the Celsius output to Fahrenheit, which for any of the American teachers out there might be a more relatable unit for some of your students, some or most of your students. And then again, we have that troubleshooting, keeping students independent and able to move along at their own pace. Then we move on to lesson 5. So lesson 5, we're going to be using our humidity fidget to read temperature and humidity. So here we learn that a fidget can actually do more than one thing, or at least some fidgets can do more than one thing, and some fidgets can house more than one sensor. So in this case, we, again, import those libraries, so importing the 2 types of sensors. We need to create software objects for both sensors. So we are only using one fidget, but we're using 2 different sensors within the fidget, so we have to create 2 different objects to represent those 2 different sensors. We don't need to address because it is a smart fidget. Then we do need to open both of those objects. So we need to open our humidity sensor and our temperature sensor, giving both time to connect. Then we are going to use our polling method, again, the while loop with the sleep time, to pull data from our temperature sensor. So in this case, I am going to demonstrate this code for you here. So we copy, we paste it in, and we run our code. So as you can see here, we can see the temperature and the humidity being printed. So you'll notice it's very warm in the room I'm working in right now. So if you want to manipulate your temperature and humidity just to see some changes in it, you can either blow on the sensor or you can hold it in the palm of your hand and you'll see the humidity drastically rise as well as the temperature increase. That's a good way for your students to check to see what the data looks like and how whether the program's working correctly and to see some changes in that data going up and down. Now we have to stop any program that we're using polling or that's continuously running. We do need to stop the program before we continue, or else you may get errors in your next programs because you can't access a fidget from 2 different programs at once. They are only able to use one program at a time. So make sure you stop your program. It's just a good practice to get into as well. So we have a little explanation showing or telling students why one fidget can produce 2 sensors. So it's a really neat thing about fidgets. Then we have some practice. So here we're more practicing our if statements, and again, using that output from our sensor to manipulate what our program does. So in this case, if the humidity is above 30%, you want to print that the humidity is high, otherwise print that the humidity is low. Or in the next one, print if the temperature is above 21 degrees Celsius. If not, print the room is too cold. And once again, we have that troubleshooting. So at this point, students are actually done their basic getting started kit lessons. So it's only 5 lessons to learn how to use all the devices on your in your getting started kit. Then we really push students into problem solving, into practicing, and into a more creative space. So our smart fidget practice is, again, pulling in those elements that they've used in the practice to create a final project. So So piecing together those puzzle pieces of what they learned and forming the connection of how this applies in a real setting. So in this case, a temperature indicator using the smart fidget, the humidity fidget, and their LEDs. So they're using that lesson 5 if statement to determine what the temperature range is, and then turning on that green LED. Then if the temperature is outside of that range, they're going to turn on that red LED as well as output the exact temperature to the user. So again, they were pulling bits and pieces. We're starting to combine fidgets together. So combining one of our simple fidgets into our smart fidgets and taking those puzzle pieces and really putting them together, forming those connections, getting students to engage with what they're doing. And with that, we move on to our final challenge. So our final challenge is to use all elements of our Getting Started kit. And in this case, we build a thermostat. So this project is really great because again, it pulls together all of the pieces students have worked on previously. So it's getting them to apply what they've learned in a new situation. So for example, if you remember, students counted their button presses in that simple fidget lesson. In this case, every time the user presses the green button, you want to increase the set temperature by 1 degree. So again, we're counting button presses. And then we're checking what our temperature is and seeing if it's within the set range, and turning on our LEDs. So again, we're taking those elements that we've already established and again, applying them in new situations, seeing how they can be used in different ways and getting that real world connection of seeing, okay, this is how an electronic thermostat could work, and getting students again engaged in building. And once students are finished that challenge, they are in fact done the Getting Started course, the baseline Getting Started course. So as of recently, we have added more advanced lessons, which we are really excited about. So these advanced lessons take a deeper dive into some of the features of fidgets. A good beginner starting bonus assignment is this LED brightness lesson. So in this lesson, students will actually learn how to dim their LED using a feature called duty cycle. Let's see if this shows up on the camera. Here we go. If you take a look at my kit, you'll notice that the LED was quite a bit dimmer than it was the first time around. And I'll run that code again. There, that's a bit better. And you can see that dimming of that LED. So again, students get the code sample with some of the code they're familiar with, and then a new feature. We explain what duty cycle is and how to set the duty cycle. You set it between 0 and 1, 1 being the brightest, 0 being turned off. And we have some practice. So students explore what their LED looks like at different settings. And then we modify our code to slowly increase the brightness and decrease the brightness again, seeing how we can use these different elements and manipulate these different elements in our code. So that's a good simple bonus assignment for your students to see a little bit more of fidgets. The next section is events. So events do require a bit more of a advanced knowledge. So you will want to have students with a bit of knowledge of methods or functions because they are used in these lessons. Let's let's take a look at the button first. So previously in the first 3 lessons, the first 5 lessons, we used an approach called polling. So that was that while loop to pull data from our Phidgets. So events are another method of pulling data from our Phidgets. So in this case, the button, when it's pressed, will output 0. When it's released, will output 1. So I'll show this code sample quickly. So if I run this code, you'll notice that the button state is 0. That's all that's being printed. It's only being checked once. When I press the button, you'll see the output change to 1, and it'll only output once. I release, it goes back to 0. So events will only run when data from a sensor changes. So what we do is we import our libraries the same as last time. We create our objects, we address our objects, and then we subscribe to events. So subscribing to an event tells your program to start listening to the Phidget. So in this case, we're going to start listening to that button, say, is anything happening? Is anything changing? And just keeping an eye on that button. Then we are going to open our Phidgets. So open again with that wait time, allowing that connection to happen. And then we're going to just have an empty loop just to keep our program running. And then here in our event, our state change event, we are going to have our print statement. So this is what happens when the button is pressed. So this event will only run when the state changes. So it's just a bit of a simpler way. This is great if you have students who do want to do a bit more with their Phidgets and want a bit more customizable nature. It's great for students who are interested in gaming and just even checking out what you can do with events and learning a bit more about methods. So in this case, again, we have our explanation of what events are. Then we have our practice. So we compare that code to our polling method to see how things change. We see how changing the loop repeat time affects our result. So again, drawing those parallels from those other lessons to see how our behavior of our code changes when we're using events. And then once again, we have just some output changing as well as adding that green button in as well. So creating a green button event. Our next event is using our buttons and LEDs together. So how do we use events with our LEDs? So LEDs do not have events, whereas buttons do. So in this case, we again import our libraries. We create all of our 4 objects still. We address all of our objects. We subscribe to events for our red and green buttons. So each button needs its own event. So we subscribe to those events, again, to start listening to those buttons to see what's happening. Then we're going to open all of our objects. So all 4 objects need to get opened. And then we're going to have our global variables, which are going to track the state of that button, which will be used to turn on and off our LEDs. So then we have our while loop that uses those 2 Boolean variables to turn on and off our red and green LED. Now, where do those 2 Boolean variables get set? Well, it's up here in the events. So this event, the red button state change, will only run when the red button state is either pressed or released. And we can set that Boolean variable that we had down below to that state. And then the same thing for the green button. Again, we're just listening, tracking. So in this case, we're getting an on and an off very simply. Again, we're doing that comparison, drawing that comparison to that polling method we did before, seeing how the output changes, seeing how this different method changes how your code behaves, and maybe would be better for certain uses versus other uses, and getting that, getting students engaged and seeing the evolution with adding events. Next, we have smart fidget events. Again, we're doing that same method. So we're going to have a humidity event, a temperature event. Again, we're creating those two software objects. We're subscribing to the events, again, listening to our two sensors in our humidity fidget to see what's changing. And then we're going to open both of those, again, keeping our program running. Again, we have an explanation and that tie-in to see how things are changing with the new knowledge that students have of events. The next one is a really, gets into more of a new space in Phidgets, which are attach and detach events. So every Phidget has an attach event and every Phidget has a detach event. So this is when your Phidget gets plugged in and unplugged, or for some odd reason, disconnects from your computer. So this one I will show. I'm going to run that. So as you can see, we've attached right here, we're attached. Now, if I disconnect my humidity fidget, watch what happens. Detach. So we're not getting an error, we're getting a detach event. Now, if I plug my fidget back in, our code can start running again. We're once again attached. So this is really great if you want to switch out fidgets as you're using your program, prevent errors. If you're running anything that's moving, it's really great to have these attach and detach events. So again, every fidget has an attach and a detach event. So your LEDs, your buttons, your smart fidgets, your simple fidgets, they all have these attach events. So we have our temperature change event. So this is a data event. So the events in the first lessons are data events. Then we have our attach event, which will listen to see, is our fidget connected? We have our detach event, which will listen to say, is our fidget disconnected? Or can I not find my fidget? And we have to subscribe to each of these three events after we create our temperature sensor here. So we subscribe to a data event, we subscribe to an attach event, and we subscribe to a detach event. And then we open our fidget and keep our program running. Again, we have some use cases of when you would use or not use an attach and detach event, and some practice questions to see what happens when we plug and unplug and do different elements in our program. Now I'm running out of time a little bit here, so I'll just shuffle through these last ones quickly. So our data interval, so events will run. So we're listening to our button or our data event or our attach event. We listen to those events and they will run and they'll be checked, I should say. The fidget will be checked every certain amount of time. So we can actually set that time by setting the data interval. So similar as when we were using polling, we were using that sleep time to regulate how quickly the loop was being shuffled through. So this is similar, but it's using events. So it's setting that data interval. So how often are we checking for change in our device? Again, we're manipulating the value and seeing what is, how that affects our output and what's happening. The last two lessons I'm not going to demonstrate. They follow the same path of, they have a setup section and then a code section, followed by a practice section. So in this case, the addressing section, you will want to partner up with two students together because they're going to be using two of the Getting Started kits. So the first one is how to use two or more smart fidgets. The second one is two or more VinTubs. So for example, if a student wanted to create a game that had each student having a Getting Started kit, this is where you'll want to learn how to use those elements. And the key here is that SIN number that's on the back of your Getting Started kit. So I'll click into this quickly. So we have a setup section showing how to connect the two kits. And then the real difference for using one VinTub versus two VinTubs is setting the VinTub as part of your addressing. So the SIN number that's on the back of your VinTub will have to be inserted here, and that distinguishes which ports you're talking to, so which VinTub you're talking to. And we have some applications. So those are the advanced lessons. I know that was a lot of information. Again, the recording will be posted. If you are interested in learning more about Phidgets, please check out more webinars under news, or feel free to email us at education@phidgets.com. If you're interested in purchasing Phidgets, this buy tab is really where you're wanting to go. So this is where your Phidgets Getting Started kit order form lives, where your Rover kit order form lives, and where your Phidget devices live. So each of these devices is supported by a tutorial and has projects associated with it. And they're great extensions for that Getting Started kit. As well, if you go to phidgets.com, as an educator, you will receive 40% off any Phidget from the website. So it's a really great resource for you guys to have. Thank you for coming to this Phidgets webinar. If you have any questions or any comments, please follow us on Twitter at phidgetsedu or email us at education@phidgets.com. Thank you very much.